Russian helicopters from the Mi family are known and respected all over the world. Military and civilian aircraft are created at the design office of Mikhail Mil. One of the main factories is located in Rostov-on-Don. Night Hunters Mi-28N attack helicopters are manufactured here. Rostov-on-Don is in the south of Russia. It's a major historical, industrial and administrative center with a population of over 1 million. It is 1,109 kilometers from Moscow, a journey of 1 hour and 45 minutes by plane. The factory was founded in 1939. Initially, it manufactured aircraft propellers and planes. 20 years later, the company moved entirely to rotor-wing aircraft. One of the latest developments of Russian constructors is the Night Hunter. The Mi-28 helicopter can work at any time of day, in any weather and in the most difficult climatic conditions. This fighting machine can perform various aerobatic maneuvers, fly backwards and sideways, and can move at very low speed to a height of 5 meters. In general, the Mi-28 has a lot of advantages. This impressive set of flying qualities is the result of a long selection process carried out by aircraft designers. Specialists at the Mil design office were not afraid to experiment, and as a result, the new helicopter fully justified expectations. Planning and improving the construction of the Mi-28 continued for almost 3 decades. For its flying and fighting qualities today, it's one of the most reliable and effective attack helicopters in the world. You could say that the Mi-28 is a new stage in the development of Russian military aviation. Characteristics of the Mi-28N attack helicopter. 2 engines with a capacity of 2,200 horsepower each. Normal takeoff mass 11 tons. Maximum speed 300 kilometers per hour. Dynamic ceiling 5.5 kilometers. Flight range 450 kilometers. Crew 2 people. The Mi-28 helicopter has excellent maneuvering characteristics. It can do all the maneuvers that helicopters are capable of. It has to have that high maneuverability to cut down on the preparation time for sighting, to cut down on repeat sighting. That's when it has to go to the same target again and again. That allows the helicopter's level of danger to be low, because it's in the enemy's range of fire for a much shorter period of time. The faster it gets out of there, the less chance it will be hit by the enemy. A military helicopter is a combination of various metal alloys, composite materials, complex electronics, and high-precision weaponry. At the helicopter factory, universal metalworking machines are installed. Various parts are made from titanium, magnesium and aluminium alloys, and steels of various kinds. This is the most heavily automated section at the entire factory. For this enormous rotor-driven machine, precision in the details is very important. A part can't differ in size from the standard by more than 1/100th of a millimeter. This difference can't be seen with the naked eye. These are modern machines that make it possible to reduce the labor involved in manufacturing parts by at least 2 to 3 times over. For some parts, we can even manage to reduce this by 4 times. We exclude the human factor. A person can get sick, fail to turn up for work, or make some error. The machine always does the same thing, with the same degree of precision. The cutter elements have 5 degrees of freedom. This makes it possible to cut the metal into parts of almost any configuration. There's only a limit on size, up to 2 meters. Dozens of tools are required for making the parts: rotary tools, bores, screw taps, chisels and drills. The machine operator doesn't have to change them manually. This is done automatically. Up to 80 different tools can be installed in the machine drum. They do their work with incredible precision. At the same time, in another workshop, longerons are being woven, the base of the rotor blades of the future helicopter. One of the latest technological innovations at Rosvertol involves not using metal in blades. The metal has been replaced by composite materials. This is a longeron from the main rotor of the Night Hunter. It's very durable, and for its large size, it's quite flexible and light. Longerons are made of fine thread, which is very strong. It's made of 4 fiberglass filaments woven together, which are 7/1000 of a millimeter in width. With a length of almost 8 meters, the longeron weighs less than 100 kilograms. And it's also quite flexible. It's hard to imagine that it's made of fine fiberglass filaments. First of all, 200 of them are glued together in a row, creating fiberglass ribbons. And then with a machine, these ribbons are placed together crosswise to create the form. To make the longeron, the machine has to make 144 runs and use almost 3,000 kilometers of fiberglass filaments that are glued together into strips. These strips make the longeron more durable and stop it from shattering when it's hit by a bullet or a shell. Heat treatment makes it possible to create a single whole part from the threads. They're rubbed with a bonding agent, and under pressure they're baked in an oven. Then the form is removed, and a durable and light longeron is left behind. Tail sections are attached to it, and the blade is complete. Each blade is tested for the correctness of its aerodynamic profile. A measuring machine takes 3.5 hours to pass over around 500 control points from both sides of the blade and compare the indications with a computer model. The blade of the helicopter rotor performs the same function as a wing on an airplane. It creates ascension power or lift. The forepart of the blade is called the longeron. The front section is protected by a titanium sheath under which the electrical anti-icing system is located. The longeron has tail sections attached to it like feathers on a bird's wing. In each of them there's a hexagonal cell core. The blades are of a rectangular form and have arrow-shaped tips. They reduce the level of noise made by the rotor. Unlike other helicopters, the Mi-28 has a rectangular form and arrow-like tips. They reduce the level of noise made by the rotor. This improves the camouflage of the helicopter. The blades of the Night Hunter are profiles used with an irregular curve which creates greater ascension power and lift. The titanium sheath is needed for protection from sand and other hard particles. During takeoff and landing, the ends of the blades reach a speed of around 200 meters per second. At this speed, sand and dust that is blown off the ground by the flow of air acts like a grinding machine. Titanium protects the longeron from abrasion. First of all, reducing the weight of the main rotor makes the helicopter itself lighter, and secondly allows it to fly at higher altitudes. To reduce the weight of the helicopter, composite materials are now used in the blades, and in some cases even paper is used. It's steeped in varnish and glued together into hexagons like this. The hexagonal cells are then dried under pressure and covered with compositional plates, and the result is a light and durable material. When the rotor turns, the centrifugal force makes the flexible blade into a hard wing, which allows the helicopter that weighs many tons not only to stay in the air, but also to perform complex aerobatic maneuvers. Composite materials can't yet fully replace metal, so aluminum and aluminum alloys still form the basis of aircraft construction. But metals have a quality that limits their longevity. Acid treatment procedures help to prolong their period of service life. Before the assembly starts, all the aluminium parts are protected from corrosion. This is done at the anodizing department. The parts are immersed in baths with various acids, and a durable oxide protective film forms on the surface of the metal. This film covers the clean metal and stops it from reacting with acid in the surrounding environment. This stops it corroding. Anodizing is a long process with many stages. First, the aluminium has grease removed from it in an alkaline solution. Then the oxide film is removed from the surface, which forms naturally on the metal. Then it's bleached in nitric acid, and then it's anodized in sulfuric acid. The process takes place in the presence of an electric current. Depending on the qualities that the film should have, an according procedure is selected. The intensity of stress, the current, the temperature of the solution, the length of the procedure are adjusted. Between each stage, the parts are washed in baths, first with hot and then with cold water, to remove the previous solution. But the oxide film that forms in this way still has micropores. This may allow corrosion, and they have to be corked. In the language of professionals, this process is called compressing. Various solutions are used for this. They give the aluminium a new color, from green and gold to black or red. To assemble the fuselage of the helicopter, you need to connect a huge number of parts with rivets. This is done in the modular assembly workshop. First, holes are drilled in the parts, and then the rivets are driven in with pneumatic hammers. This is why it's always very noisy in this workshop. Around 10,000 rivets are used for one fuselage. It's very important that the holes in them are made perpendicular to the part. A rivet that's driven in on an angle will carry a very heavy load and may break. A supervisor checks the work of each riveter. To ensure that the attack helicopter has good maneuverability, besides using composite materials, the constructors decided not to use metal armouring. This made it possible to reduce the weight of the helicopter by around 200 kilograms. Shock-resistant ceramics were used as protection instead. The cabin of the Mi-28 is made of light, durable and easily manufactured fiberglass. Ceramic armour elements are glued on top of it. They're made up of these square plates. When the plate is hit by a bullet or shrapnel, it shatters, but it absorbs the energy of the shot and stops the destructive agent. This armour can withstand a direct hit by a 23mm shell. The cabin is divided by an armour partition. This reduces the probability of both crew members being hit at the same time. The controls for flying the helicopter are located in the pilot's cockpit, while the navigator gunner has the weapons controls. Making a helicopter is a laborious and very responsible process. The helicopters must be able to work at the limits of their capabilities and protect the crew in dangerous situations. In the south of Russia, in the city of Rostov-on-Don, there's a factory for the manufacture of helicopters which were developed at the design office of Mikhail Mil. Here the Mi-28 Night Hunter attack helicopters are made. Only the engines, the onboard electronic equipment and the weaponry are supplied by other specialized factories. All the other parts of the Mi-28 are made at Rostvertol. At the workshop for the final assembly, the future helicopter gets an engine, the transmission gear, navigation systems, weapons and armor. In short, everything that turns an empty fuselage into a formidable fighting machine. The assembly workshop is an enormous space that's divided into sections. Each one is responsible for a certain type of work. Here the fuselage gradually has parts added to it. Before installation, the devices are tested at the entry control workshop. Then the wiring is done. Mounting the enormous main rotor transmission is a separate process. It weighs 820 kilograms and plays a very important role. It supplies the energy to the engines of the main rotor. In complex maneuvers, the turbine shaft of a working engine reaches up to 15,000 revolutions per minute. The main rotor must make 240 revolutions a minute. It's the main rotor transmission, like a gearbox in a car, that turns the huge number of revolutions of the turbine from a small number of revolutions of the rotor. Also, the torque increases. The main rotor transmission is essentially the most important part of the helicopter. A malfunction of this part is equivalent to the death of the helicopter. The time has come for the turbine engines. Each one weighs almost 300 kilos. They are installed on the sides of the main rotor transmission. The total power of the engines is calculated with a reserve. If one malfunctions, the helicopter can return to base on the other one. After the engines are connected to the main rotor transmission, the titanium main rotor head is placed on its axle. 5 blades are attached to it later. They're not attached yet so that more helicopters can fit into the workshop. As assembly proceeds, the glass is installed. All of the glass in the Mi-28 is armoured. The side windows can withstand a direct hit by an armour-piercing bullet of a caliber of 7.62 millimeters. The windscreen can withstand bullets of a caliber of 12.7 millimeters. The invention of this helicopter was the result of a dispute, or rather a creative competition between two design offices, the offices of Mikhail Mil and Nikolai Kamov. Both offices were developing a new attack helicopter for the Russian army. The constructors and engineers of this helicopter, the Mi-28, created an outstanding specimen of aviation technology. This helicopter can fly backwards and sideways, it can turn in the air almost instantaneously, and can perform complex aerobatic maneuvers such as the inside loop, the barrel roll, and the Immelmann turn. If only such technological miracles always arose from the disputes of constructors. One vulnerable part of the helicopter is the shaft that supplies the energy to the engine of the steering rotor on the tail. If it's damaged, the helicopter will go out of control. In the Mi-28, the tail shaft has a larger diameter than in other types of helicopter. It's made from a metal pipe which is gradually rolled up inside, reducing the thickness of the wall and increasing the diameter of the pipe itself. This procedure is repeated several times, alternating with heat treatment, in order to reduce pressure in the metal. If this shaft is hit by a bullet, it will get a hole in it, but it will not be completely destroyed and will continue to work. For protection from heat-seeking anti-aircraft missiles, exhaust heat shields are installed on the engines. The flow of hot exhaust gases is mixed with the flow of the cold outside air and evenly dispersed under the helicopter. This helps to reduce the heat signature of the Night Hunter by more than 2.5 times over in comparison with helicopters of the previous generation. Particular attention is given to protecting the crew if the helicopter hits the ground. Everything possible has been done to save the crew if there's an emergency landing, even if it's a vertical landing with a speed of 12 meters per second. Design methods have been used that allow, in an emergency landing, the collapse of the construction, but the people inside to be saved. The chassis doesn't retract on the Mi-28. That's because when flying at low altitude, you don't have time to put the chassis down. And there's no way you can use a parachute. So the chassis and wheels are on the outside, so that at any moment they can touch down on Earth. Another rescue system allows the crew to leave the helicopter when a decision to do so is made at an altitude where it's possible for parachutes to open. When the emergency handle for opening the cabin is pulled, the doors automatically fall off and emergency airbags inflate on the sides of the helicopter. This allows the crew to leave the helicopter safely without being caught on the outer parts of the aircraft. The fuel tanks have a special construction. They're made of rubber with a protector. They're covered on the outside with a substance which reacts with kerosene to vulcanize the rubber. So, if the tank is pierced, the kerosene that leaks out will cause a chemical reaction that will block the hull. This system stops fuel from leaking for 6 to 8 hours. To prevent explosive kerosene fumes from forming, the tanks are packed with polyurethane foam. This material soaks the fuel up like a sponge and prevents fumes from forming, reducing the probability of an explosion. In a military helicopter, everything is arranged to protect the pilots and the most important equipment. Even the electronic units are placed outside the helicopter, so if the helicopter is hit, they can absorb some of the energy of the shot. The most important systems of the helicopter are duplicated. The helicopters go to the control and testing workshop after assembly. Here, all of the onboard systems and units are checked to make sure they're functioning correctly, from communications and the navigation equipment to the engines and weaponry. Each helicopter passes hundreds of tests and checks. Several teams of highly qualified specialists examine the helicopter inside out. Their task is to regulate the work of the equipment and conduct tests of the electric circuits. All of the systems are checked separately and in interaction with one another. One of the final stages for checking a ready helicopter is testing its weaponry. In the language of specialists, this is called cold sighting. A universal control stand with targets is placed in front of the helicopter. The precision of sighting for all the types of weaponry that are carried on helicopter serial models are tested using this stand. This is called cold sighting because shots aren't fired. Only the sighting systems are tested at the workshop. By aiming them at control targets, specialists check the precision and carry out adjustments, detecting and eliminating errors. On the wings of the helicopter, there are 4 points for suspending removable weapons, 2 on each side. Depending on the battle mission, different types of weaponry and different combinations can be installed on the helicopter. Up to 80 unguided missiles of a caliber of 80mm, up to 20 unguided missiles of a caliber of 122mm, up to 8 Igla guided missiles of the Air-Air class, and 16 guided missiles of the Attacker complex. Helicopters are equipped with a flexible gun of a caliber of 23 to 30mm with ammunition of 450 shells. The gun has 2 ammunition boxes with various shells and various munitions. They may contain high explosive and armor-piercing shells. Depending on the type of the target, the operator may choose the type of shell that's required at any given moment. And this all takes place at long distance, just by pressing a button on the control handle. Accuracy of firing is provided for by a sighting station with heat and video observation channels. It's attached to a stabilizing platform and has wide visual field angles. The helicopter is equipped with a satellite navigation system and can find its bearings in difficult weather conditions. The Night Hunter is equipped with a warning system of radar and laser detection. This gives the pilot the ability to evade the enemy's radar and laser systems. There are no limits to improvements. We're making the 28UB helicopter a training helicopter. This means that if in a standard helicopter only one pilot does the steering, in this helicopter it will also be possible for another pilot to do the steering in the front cockpit. The 28NM helicopter is now in the second stage. It's fundamentally new and also highly modernized. It has a lot of innovative features in it. It has a new transmission unit, blades and radar, a lot of innovations. Most importantly, the emphasis is made on modern, high-precision weaponry. This is one of the most important factors for a helicopter. When you fly, you won't fight the enemy with noise alone. The time has come to test how the helicopter will behave in the air. The blades have been installed on the Mi-28. Each one weighs 98 kilograms. Installing one of them takes around 20 minutes. The last link in the long chain of factory manufacture is the test flight department. Here the helicopter takes to the skies for the first time. The helicopter's been assembled and checked and is ready for operation. After the documentation is drawn up, the fighting machine is sent to its place of service. The Night Hunters usually fly to their destination.